Hi, good afternoon. Ignore the what. It's not part of the talk. Good afternoon, everyone, and hello to everybody watching online. My name is Ali Salim, and my friends don't call me this, but I wish they did, Salim Shady, because I'm a big Eminem fan. And when I get excited, I start rapping. So I'm going to be looking for confused faces to know when to slow down. Okay. And when I get a bar, just let me know. Say, that's a bar, and I'll know what it is. Okay. For this talk, we'll define the last mile. We will talk about why my team prefers Rust and touch on some case studies, basically things we've built. And we'll have a small demo towards the end. So that's me, one of the better photos that my wife took. So I work at Elsa Health and No Discipline. Elsa Health, we build decision support tools for low and middle income populations. This is Subsaharan Africa primarily. And for No Discipline, we work with organizations to try and introduce transdisciplinary thinking to some gnarly problems. Think plastic in the coast of Zanzibar and the like. I'm also the CTO of Hikma Health, and there we build health record systems for refugee and migrant populations. Big fan of math, specifically category theory, and how it enables transdisciplinary problem solving. Turns out if you define a problem logically enough, you start seeing avenues of attack. Big proponent of equitable healthcare. I have a whopping 400 ELO rating on chess.com, which, if you guys don't know, is pretty bad. And I enjoy making stuff with my 3-year-old. And anytime I have baggy eyes, it's her fault, not mine. Everything online says you need to start with a joke, so here's mine for today. I am a vibe coder. Actually, I'm just playing. Don't come at me. I know vibe coders have a lot of time in their hands because the AI is doing all their work. They have all this free time that they can come at me with. So please, I'm just joking. For context, I work in 0 to 1 settings. Most of my career has been, I start a project, and when it gets adoption, and this is typically when things end up in either government, in my case, or when there is a project manager introduced, then that's when I typically try to leave, because the excitement has died down by that point. I don't work in large organizations, so teams of hundreds or organizations with thousands of people, so your mileage may vary based on my experience. If I hear any heckling, I'll know that my wife made it in here. The organization will take you out. Nice. So last mile. If you're thinking last mile, think rural clinics, think mobile health centers, think a van with a nurse and a random guy who's volunteering in their free time, heading off for 30 kilometers into the village to try and provide some care. Think community healthcare workers, which are individuals that walk for miles and miles every day to check up on pregnant patients. Think refugee camps. Think no resources, both human and otherwise. This is a photo that we took recently. On the left, does this have a pointer? Well, there it is. On the left, the image number 1. This is number 1 is a pediatrics unit, and number 2 is a gynecology unit. And this clinic did not exist the morning of. They set it up. In the evening, when the health mission leaves, it goes back down. And typical clinics look like this. They might not be set up once and then taken down. They might be there for a long time, but that's what it looks like. Some of the early experience that I've had, which actually brought me down this whole path maybe 12 years ago now, was a clinic I went to where the clinic is separated by a sheet of clothing. It was just a curtain. And on the other side, there was a lady delivering, and on this side, a nurse was seeing patients. So we figured out that we need to do something about this. All right? So small rural clinics, low physician-to-patient ratios, volunteer doctors, high turnover, and zones with typically humanitarian crises. It also means really, really old Android devices, like really, really old Android devices that you have to work with. There's no internet. They will say there's internet once you land at the airport, but there is no internet. There's challenges with technology literacy, so we have to spend a lot of time trying to teach people that Samsung is the same as Android. So you'll talk to a healthcare provider, and they'll tell you, well, I don't have an Android phone, I have a Samsung phone. And you have to start, that's the level that we're starting at here. and extremely cultural and superstitious. So where you're taking our data, and most of the contexts that we work in, which is where I'm from as well, we have a certain distrust for foreigners coming in saying they're going to provide help. So there's a lot of superstition, a lot of culture that's developed around this, and you have to start sensitizing the community about that as well. Everything is paper. I don't think that needs to be said anymore. Everything is paper, and everything is paper that gets lost immediately. Yeah. And doctors' handwritings. Yeah, that's probably the worst part of my whole job. So we made a little quiz to try and determine for yourself if you or someone you love is building healthcare at the last mile. So have you ever seen an EHR system, electronic health record system, that loses patient records but keeps very good billing records? You might be working at the last mile. Have you seen medical records with diagnosis where you are sure the clinic has no way to make these diagnoses? You might be working at the last mile. Have you built a probabilistic model for sampling on an Android device from 10 years ago with only 2 gigs of RAM while fighting for resources with background applications? Might be last mile. Have you built critical HIV tools, critical tools that rely on internet, which you were promised would be there to support HIV-positive patients right around election time when they shut off the internet for 2 weeks, allegedly? You might be at the last mile. Now, to solve all of these problems, which I say jokingly, but each one of those has been something that has caused our team to cry, like for long periods of time, because we don't have answers to give back to the clinics when a patient they're expecting to arrive is not arriving or the services are down. And to do this, you need all sorts of different tools. And we hear this phrase that gets drilled into our heads that you need to pick the right tool for the job. And over the years, we've used many different technologies across different stacks, and we realized that the right tool for the job actually just means within your toolbox. So if your toolbox is just language A, B, and database C, there's really no right tool for the job. It's what's in there. And with this, it brings me now to the fact that some tools are better than others for more jobs, I guess. And for us, that has been Rust. It's become an essential part of our toolbox. It's the default tool that we reach for before we question, should we be reaching for this? And by this, I mean we've built some things that we really shouldn't have built. Just because Rust lets us do it, we did it anyways. Now, let's talk about why my team and I prefer Rust over other, let's say, tools and technologies out there. It's all based on consequences. You can do anything in life as long as you can face the consequences. So you make a decision, you have to live with what comes out after the decision you make. If you choose a language without a sound type system, that's what you live with. If you choose a language with dynamic typing, you have to be willing to accept what comes after that. If you start referring to your current wife as your first wife, she will start introducing you as her ex-husband. Trade-offs. This is something that I was surprised by, because everybody outside of Rust tells you before you come in that it's going to take you a long time to ship the first product. But it's ridiculously fast. I was a little bit disappointed at how easy it is to go from 0 to 1 in a programming language that keeps you from having to come back and fix what you did yesterday every time. And we really enjoy this, and we really capitalize on this. In our case, move fast and break things is very expensive, most of the time illegal. The strong type system helps us catch not only bugs in the program itself, but also algorithmic and logic bugs. And there's a crate out there in the community. I'm sure there's multiple others like this, but it's called Flux, and it lets you refine your types. So if you see a contract that a function is saying, I'm going to take a number that is between 2 and 5, it's only going to take a number that's between 2 and 5, and it won't let you program anything else anywhere else. And the libraries, of course, that exist out there are of high quality and are performant by default. All of this leads to faster time to deployment. And because we have faster time to deployment, we start doing things that maybe we shouldn't sometimes. We build everything in-house. It works really well for us, and we're able to quickly prototype on different things. Here are some examples of things we've built over the past X number of years. Don't want to date myself there. But one of them is a blood glucose simulator. And this was built specifically for a population of diabetic patients where testing out different treatment plans. And what we do in this is we simulate the different cells. This is millions and millions of simulations, different cells, different glucose molecules, different organs. So you have your pancreas, you have your liver, you have your circulatory system. We simulate red blood cells, we simulate sickle cell, all of these different things, and they're all expected to run on a relatively modern Android device. We built the first version in NIM with the promise of compiling to C and then embedding it, shoving it down in there. And it worked really well, but we had a few problems with performance. We started porting things over to Rust, and it worked significantly faster, which was a fun experience for us. I also still love NIM and use it, but in many cases where I need to embed things in other applications in constrained environments, I go for Rust. We have our own human state ontology, where aside from doing decision support using machine learning approaches, we try to define the whole human state physiology as a graph of sorts using ontology logs, a concept from category theory, and try to compute it instantaneously. And Rust's type system allows us to define the types first and then write the program that matches the types. Of course, because we can, we built our own database system for offline events and many, many different things. Resumability is the second thing that Rust gives me and my team. I couldn't find a word for this. Unfortunately, I read a paper yesterday that actually talks about this. It's the theory of programming as programming is meant to be a way for programmers to build a theory in their own brains. And you should read that paper. I'm probably not doing it enough justice. But resumability is the ability to come back to a project after 6 months and still be able to pick it up. And that's something that, as we all know, is very difficult in general. But the strong type system lets you touch parts you're unsure of. And if it blows up right here, not later. And using tools like Flux, which is a package that lets you do refinement, you're able to immediately understand what the function is agreeing to beforehand. The documentation is awesome. The line between comments, examples, tests, and documentation is very blurry. So everything that was written before, the concept of comments go out of date is less valid, not completely invalid, but less valid because the comments can run. Okay, and it makes it easy to remember a function you wrote a few weeks ago. The community projects are generally higher standard than other communities, and the phrase last updated 8 years ago, which was enough to send chills down my spine a few years ago, is no longer a thing I'm concerned about. This also leads to, surprisingly, when you leave a project for multiple years because of funding or regulation processes, when you come back to it, the packages are also a year older, and you don't have to worry about it so much because if it worked then, it's likely it still works now. And on resumability, sometimes it's because, just to touch on this, sometimes it's because you start a project, you have an agreement, let's say with a local government, you start a project and elections happen, everybody gets replaced, and you have to wait for the next election cycle. So we've had a project that had a 4-year gap, 5 years in the specific country that I will not name, had a 5-year gap just because the policies changed. Right? So a lot of these things outside our control. If the programming language can help us at least make some of the things we can control easier, that's a little bit better. Okay, prototype versus production, very similar to 0 to 1. What you prototype, it's very easy to ship. This has pros and cons. The con is that, of course, what you prototype is very easy to ship. The pro is, of course, what you prototype is very easy to ship. Oftentimes, and this has happened a couple of times for us, where we leave a clinic with a demo, please do not use this. And we come back and they've already used it and there's patient data in there, which typically becomes harder because now you have to start dealing with migrations. But our first version has to work for us. It just has to work, no option. And confidence. Confidence is super critical because having access to network is the exception in our case. So most of these deployments are offline for months, right? We have some deployments that have never come back online since 2020. And it's just because there's no internet, nobody is bothered to bring power to these areas. They just all charge on solar panels and generators. Portability is, I think, the last thing that really keeps us using Rust. like other speakers have mentioned, it's easy to build and deploy across different platforms. Whether you're building for a $50 Android device, you're building for a $2,000 computer, or you're building it so that it can get embedded into an EHR system that has the vast resources of AWS. Right? You can do it for any one of these with confidence. Also, you can embed it in an ESP32 that costs $10. Don't ask me why, just because. And you can deploy anywhere that healthcare happens. It happens here, that's where I'll be. I like this quote from a YouTube channel called No Boilerplate. It says, in other languages, simple things are easy and complex things are possible. In Rust, simple things are possible and complex things are easy. Okay, now we'll jump into some case studies. Nobody's telling me to slow down, so I'm guessing this is fine. Here, this is a representation of a decision support tool. This is an algorithm on the left to compute whether two drugs interact with each other. Of course, if you choose to build a database of all the drugs, you will constantly have to keep building it because new drugs come out and new formulations come out. But if you focus on the compounds and the chemical components, you're able to compute as long as you know the ingredients of whatever the drug is, which opens up vast new opportunities where you can start talking about traditional medicines and things like herbs. As long as you know what the composition is in there, you can calculate how this is going to interact with your TB medication. So the problems we're trying to solve with the clinical decision support tools are around the imbalance between the number of physicians and patients. In the US, as of a few years ago, it was 600 patients for every one physician. In many parts of Sub-Saharan Africa, it's 20,000 or 30,000 patients for every one physician. And unfortunately, all the physicians go to the cities because they also want a good life. And the rural areas are left with, without trained physicians. And because most of the countries have, for most of the countries, we don't have trained health personnel, whoever is there has to step up. And we end up with high misdiagnosis rates and extremely high drug interactions at the point of drug dispensing. And our solutions for this are to package in a core library that is built in Rust, and it does symptom and patient assessment as well as drug interaction assessment. And remember, all of these are happening offline, so they all have to happen on whatever device you find in the facility. All right, just to mention, the algorithms cover over 220 conditions, all the way from pediatrics to non-communicable diseases, infectious diseases, HIV and AIDS, and 1,000 different drugs that we are sure are covered because we work at the chemical compound level. We've done over 100,000 patient assessments and have a few ongoing studies. Back to the tech literacy. I love this photo because this is Kevin James, an engineer I work with, phenomenal. And he is training the users on how to do probabilistic reasoning with bottle caps. What we thought was a 15-minute session took 2 weeks, but it was really, really fun. The tools are built in React Native. We picked React Native a few years ago because it gave us over-the-air updates, which we really loved. It's really helpful when the person has internet, but it only goes so far as that. The core algorithms are built in Rust and are handling all of the actual data processing and actual computation. The React Native aspect is just a thin client for it. And moving forward, we're transitioning most, if not all, of our tools to Tori for a more unified story, and partially because a few months ago it took I think it took between 3 and 4 days to upgrade one React Native version to another, just because of how many freaking breaking dependencies there are between one version and the next version. Of course, we also get some nice niceties like smaller binaries, improved performance, and the ability to share between different platforms. We didn't make this choice lightly. Over the years, we have tried JavaScript, writing our core algorithms in JavaScript, which of course is the first thing you do in a JavaScript environment. In C and C++, I think at which point one of our team members quit, in NIM, in Swift, and in Kotlin. But of course, all of these things work really well. They all have different trade-offs, and we weren't really willing to make many of them, and Rust seemed to fit the bill for all of them. This is a second case study I'll talk about. This is a refugee camp, and for obvious reasons, I will not mention where it is. But There is no infrastructure in here. There is a list of health volunteers, and they're all using the tablets to see patients. So patients come in through, it's like a makeshift hospital. Patient comes in, gets registered, goes to this clinic, goes to that clinic, goes to that clinic, gets medication, goes back home. Or in this case, back to their camp, to their compartment. There's no infrastructure, there's no internet, there's no power. And here we built a small, surprisingly fast to build. We built a small local offline server that turns any laptop we find on premises or any laptop that a volunteer brings into a local server that allows for data sharing between the different devices. It handles encryption, it handles querying, it handles sync logic and conflict resolution, all of it right there. And since all you need is a router and one of the, either the doctors or the volunteers to bring a laptop, we can turn any encampment into a fully connected EHR system. And when they come back online, because they have to do reporting, they have to talk to their donors, they can sync it back to the server. This was the first time I saw a laptop with 3 gigs of RAM, which was really fun. I thought the numbers went up in different orders, but 3 gigs is there. And Rust lets us do cross-platform deployment. What we find, the laptop version, the operating system version that you have, there are no surprises. Windows is always surprising, but other than that, there are no surprises when you do a deployment there. And this gives us confidence in shipping. Most of these apps will never get updated. There's no error reporting. You don't even get calls from the field that something didn't work. They just put it down and go back to what they used to use before. Yes, and of course, the community has awesome encryption libraries. Third and last case study I'll talk about is the HERS system, which is the Health Environment Record System. We are building at Hikma Health, where we try and combine climate information or environmental information with patient health information and try to bring all of these together into the patient visit room and try to inform the decisions that the clinician is making and the resources that the clinic is allocating for better care of patients now and in the future as climate change makes these situations more complex. For this, we're building multiple parts actually of the stack, and a lot of it is centered around time series forecasting and analysis. So you take the patient trajectory for all the patients, 100,000, maybe 200,000, and you take the current changes in the environment. And you don't stop there because the patients, in many cases, are migrants. You have to do a time series of where they came from and all the parts in the middle that they passed through so you can provide better care. And with this system actually was first built in Python, then we moved some of it to Go, then we moved some of it to Rust, and I think a lot of it is staying in Rust right now. We're able to get really, 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 really good performance on very, very old devices. And the time series and data analysis algorithms that exist in the community are really, really good. I think Argus is one of them. And we basically had to throw away some of the things we had implemented ourselves because the community packages were working really well. And that has been a great win for us. The desktop application, which is a studio that runs at the clinic or camp, is a Tori application. The mobile apps are Tori apps or React Native with a Rust core. And we also embed this in giant EHR systems to ingest patient data right there. And our server API is still in Go, but it communicates with a Rust backend. Now that was also painful. You think the JNI is painful? I think this is painful. Time for a demo. Awesome. OK, so this, hold on. OK, so what I'm going to demonstrate now is a new tool we're prototyping with a few researchers and trying to get into patient trials to assess, monitor, and track tremors. Tremors are involuntary muscular or neurologic movements. You've seen hand tremors. It can happen anywhere. We're focusing on hand tremors. And with that, we're building something called a wand. This is the Leviosa wand. OK, Harry Potter fans, I see you. All right, so we're building this wand with a few researchers and trying to evaluate the use of it. In the Western world, you have all the resources you need. If you can afford them, you have all the resources you need, but you need to wait for these like long periods of time before you get your next evaluation. These snapshots in time really miss a lot of information in between. In what is not the Western world, you can have as many hospital visits as you want. It's just hard to identify, monitor, and track the condition that you have. Okay. So this is a wand. It is supposed to be working, and it's modular. So all of these pieces are 3D printed, and you can replace any part you want, which is great because this broke a few times as we drove up here for this presentation, and we just reprinted. I think we reprinted once in Portland, and we bought an ESB, a new chip in San Francisco. We drove from Phoenix to here. But yeah, so this is modular, and everything is replaceable. This whole thing costs under $30, and it communicates over Bluetooth or through direct chip to whatever computer is there locally, and helps you track and monitor patient progression. Okay, I think I have a few minutes to do this. So I'm going to share my screen here. Give me a second. There you go. Of course, I have my Zen browser. I love Zen, but it's causing a strain in my relationship with my wife because I convinced her to move from her browser to Zen, and it's in beta, and everything keeps breaking, but I love it. So I'll share. Okay, I need to start it here. Okay. All right, well, this is coming up. Yeah, as you can imagine, everything is built in Rust. Everything except the UI layer of the app that I'm about to show, and it's just because the JavaScript ecosystem is pretty much still the best, the gold standard there. And due to my team's experience, it's a little bit easier to build front ends that way. Okay, here's what the app looks like. I don't know, can we see that? All right, nice. Cover up these tabs, actually. Who knows what's there? All right, so this is the nervous wand. I came over here, let me bring it back here. Okay, the app looks exactly like this, minus the 3 dials at the top. Like I mentioned, we had to rebuild this a few times, so I'm not taking any chances on stage. I'm going to play the demo. I'm going to load the demo data set. As part of our research, we collect a lot of this data. Of course, all of it is anonymized. It's all just time series positional information anyways. This demo information is of a patient, and we'll see what happens. They would stand next to their physician or the caretaker and press start. And at this point, for 30 seconds, we'll be collecting the movement. So depending on what we're trying to evaluate, we'll be collecting different data for different movements. Some patients have to stand, have to hold it still like this. You see what I have a little tremor there, or you can be doing this, or depending on exactly what the situation is, the healthcare provider will pick from a set of predefined activities. All right, here we go. And we start at 35 because the first 5 seconds are always just, I start now? Now? So we give it a little buffer time, and we pick the 30 seconds that we want. All right, so this is not my actual data. This is a data set that exists. You get a little score at the top. Of course, all our clinicians already know we're still in research phase. A few things break, and I'll show you that in a second. You get your results. You also get some readings and a breakdown here. And this might be a good place to mention that tremors can have different causes. Too much coffee is a cause, right? Excitement is a cause. Giving a presentation is a cause. I'm really glad I'm not doing this right now. Yeah, so I'll do another one really quickly. I'll start a new assessment. And this is called the God Save Us All data set. This is what we did when we were testing this out a few months ago, and we gave it to my daughter to try and do this. And she took it and ran. She ran and she ran and she ran, and we had to refix it after that. So we'll let this load. What we're doing here is a simulation where I have the data set aside, and I stream it in as it would normally. And now that I'm up here, I'm now thinking that maybe I should have just made it all available. We have 2 databases. One is in the app, and one is in the chip. And we're experimenting with different strategies. One is streaming directly from the wand to the tool, and the other is storing it here first and then sending it over. We can also do analysis here, but would much rather keep the data in one place. There. OK, so of course, it breaks. Everything just breaks immediately. If this could catch on fire, it would catch on fire right now, given how my daughter was running around with it. So we're still working on it, and we like to include these failure examples when talking to our physicians so that they understand that it's still in testing. And I think that's it for me. Thank you all. All right.
Have 6 more minutes if you want. Okay.
We can do questions. If there's any questions. Notice I said questions, not comments. I'm just joking. Yeah. Yeah. Thank you. Yeah. Yeah. Yeah.
Did you have issues finding reviewers, like competent reviewers, that chicken and the egg problem of I want to write code, who's going to review it?
Yeah. Yeah, that's been challenging, but oh, thank you. Yeah, thank you. The question is, when I was introducing Rust first to my organization, how did I deal with the chicken and egg problem of I want to use a new technology, but there are no reviewers or existing expertise in it to review the technology before it goes out? Yeah. No, this was difficult. In our team, we found mentors outside the organization to help us adopt as well as do reviews on the projects and what we're working on. It does help that I work in really small teams, like 5, 6 people, and they're all like highest caliber nerds who just like riff off of each other anytime anyways. But in that case, I would advise you get someone, like we did, a mentor from outside the organization to check in, someone really invested in the work you're doing, because as the work that we do, you really can't afford to pay someone that much. Yeah.
Okay. Hello? Okay. Thanks for the talk.
Yeah.
Could you expand a bit more on the resumability aspect
Yeah.
of Rust in your experience? Was there something specific about Rust that made it particularly resumable, or do you just mean those practices you listed on your slides?
I think we all heard that question. It's kind of a two-parter. So there's good software engineering practices that you have to bring with you that will make it easier to keep your project maintainable over a long period of time. But specifically with Rust, there is the 8 years last updated thing, where after you come back after 3 years, you know that if you work then, it works now. You don't have to. You should, but you don't have to so much go into the dependencies anymore. As long as they didn't change then, they'll still work now. But the type system keeps you accountable. If you touch and break one part, another part breaks immediately. So that's more of a type system kind of benefit, as well as the extra crates, like I think one is called Aorus and Flux, that let you do refinement on your types. I think that has been a game changer for me. I pretty much start a new project and then install that, then remove it later. Because when I have that type of refinement and control over my types, I have more confidence later when I come back that the function signed a contract, and it's always going to keep that contract. There's also a paper called Big Ball of Mud. Have you heard of it? How all architecture just ends up, like no matter how much work you put up front, all architecture just ends up being a big ball of mud. Yeah, there's like the nice modular system and the crate system at the systems level programming type of environment, which is really awesome about Rust. It lets you contain all of this mud in one place, and later it doesn't splatter into everywhere else. Yeah.
Okay, we have time for one last question.
Hey, thanks for the talk.
Yeah.
In terms of your front ends in JavaScript and then everything else is in Rust,
Yeah.
how do you find debugging across the language boundaries, and how do you deal with API issues when the front end doesn't understand the back end or someone's made an assumption?
Yeah. That's a good question. It's a good question with 3 answers. One is, in a team of 5, typically, which is my context again, typically means everybody has touched everything. So the API layers tend to be a little more stable, but also we are big proponents of, it's Jonathan Blow and Eskil, and this is one thing that they bring up in every interview that I've seen, is standardizing the API layer first, And that's the agreement. Nothing else changed. The API doesn't change. If you have a change to the API, you never break it. Actually, I think it's Hikma. You never break it. You introduce a new API. And this one is forever supported. You just made a bad call. It's a bad call, man. Yeah. The only other thing I'll add here is that almost everything we build is offline first. So even things like running integration tests are very cheap for us because whatever you call in the JavaScript side calls the backend immediately. You don't need to make a network request and the like. And it's just easy to look at the project as it is and all of the dependencies there. We haven't really had API calling issues except for between Go and Rust, and that, but that was server side. Yeah. Thank you.
Thank you, Ali.